Hello, I'm Ángel Perles, coordinator of the Horizon 2020 project Collectioncare, an affordable service for the preventive conservation monitoring of single cultural artifacts during display, storage, handling, and transport. I will start my presentation with an introduction of the departing problem of the project. Then I will focus on a brief description of the context of the Collectioncare project, followed by what is Collectioncare and its current status. And finally, I will summarize the next steps of the project. Let's start with why. So I can describe the needs that led us to propose this project. Environmental factors such as temperature, relative humidity, light, ultraviolet radiations, among others, threaten the conservation of cultural objects. For this reason, continuous monitoring and evaluation of the environmental parameters are a fundamental part of preventive conservation principles. However, recording environmental data is not necessarily sufficient because an effective preventive conservation strategy should link environmental monitoring to predictions of the kinetics of alteration of materials composing the objects. So it is not the same a wooden object than a metallic one. As a result of this point of view, it was born the idea to create a project guided to solve this need. The Collectioncare project. The European Commission has been a strong promoter of research initiatives aimed at preserving, conserving and enriching Europe's cultural heritage. In 2017, the European Commission opened a call within the Horizon 2020 Research and Innovation Programme for projects with topics related to innovative and affordable solutions for the preventive conservation of cultural heritage. 3 projects were granted, which are the APATS project, the SenseMatch project, and the Collectioncare project. As for the Collectioncare project, it began in 2019 and will finish in 2022. Collectioncare project counts with an interdisciplinary consortium of 18 partners from 9 different countries of Europe, which includes renowned research groups and companies, as well as a large number of museums. At the same time, the project comes with an external advisory board of recognized experts or important institutions. For more information about the project, I suggest to refer to the paper presented at the Florence Heritage Conference. And exactly what is Collectioncare? The main objective of Collectioncare project is to develop an innovative decision support system for preventive conservation that responds to the needs of small, medium-sized museums and collections that in general cannot afford this type of solution. To do so, the system will integrate the latest technological advance in sensor nodes and wireless communications, cloud computing infrastructure and big data analysis, material degradation models and normative standards for preventive conservation, and finally, a user-friendly output. All this in order to obtain data and analyze it information to suggest appropriate conservation guidelines for museums' collections. This is a more detailed view of the previous slide that I will use to further explain each of the sections that make up the Collectioncare system. I will also briefly explain what has been done and where we are now in the project. Attached to the objects or closing out of them, the idea is to install wireless sensor nodes that measure and transmit in real time the physical parameters of the environment that surrounds the objects. We designed a sensor node using Sigfox and LoRaWAN technologies that provide us with a battery-powered long lifespan, around 10 years, sensor capable of dealing with complex scenarios such as thick walls and long distances. It is important to remark here that we are considering the whole cycle of an object, which includes its display, storage, handling, and transport. Despite the situation, in July we decided to deploy a batch of the first iteration of this sensor node in two of the partner museums, the Arts Museum and the Fine Arts Museum, both located in Álava, Spain. Here we successfully tested the deployment techniques such as real radioelectric space analysis and physical attachment methods. The next block of the Collectioncare system deals with cloud computing and big data. Here we decided the appropriate cloud infrastructure to deal with the storage and the processing needs of the project. And we decided to go with the Amazon Web Services offering. For example, we selected Amazon DynamoDB to store environmental information and object-specific data. We have started gathering information on the selected cultural objects such as their conservation status and the historical environmental data collected by the museums using data loggers or manual recordings. This information has been transformed to be accommodated in the designed Amazon DynamoDB database infrastructure. Also, the live data being collected by the installed sensors in the museums of Álava is being stored in real time in these databases. The next block of the Collectioncare system is the degradation models and the preventive conservation normative 1. The idea here is to compile the actual degradation models and the preventive conservation normative and translate them to computer algorithms to be executed in the cluster infrastructure. These models allow us to predict the evolution of the degradation of an object according to the type of material that composes it. It is important to remark that the project considers only canvas painting, wooden objects, paper objects, and metal objects. In addition, in order for the system to provide preventive conservation recommendations for the objects, current preventive conservation normative and standards are being considered. As an example, the left side of this slide summarizes part of the VTT model of wood mold growth. On the right side, a code fragment in Python programming language is shown. This is part of the translation of this model to the cloud infrastructure. Our goal here is to make this translation accessible to anyone with very basic programming skills. Finally, we need to show the results of the analysis to the different stakeholders. To do so, we want to provide a user-friendly environment. At the moment, our plans are to use web browser visualization or to integrate the Collectioncare system in the museum's collection management software. As an example, the data being generated in Álava can be accessed using a web browser, where the graphs you see in this slide can be seen. This graph may seem interesting, but not very useful if you are not an expert in the field. But the one on the right side is an European norm 15757 control chart, and this is a more useful if you are complying with such regulation. This is the type of output that we seek for our system. Finally, at what point are we now? Right now we are working on the refinement of the sensor node, adding extra sensors and enhancing capabilities. From the cloud computing, we are working on security and edge computing. From the point of view of degradation models, we are translating the degradation models to computer algorithms, and from the point of view of reporting, we are working in the definition of real needs of the users and the development of the user interface. At the end of the project, we will demonstrate the Collectioncare system capabilities in all partner museums, that they are located in Athens, Brussels, Álava, Copenhagen, Riga and Valencia. Also, the Collectioncare system will be demonstrated in an artwork transport. Our partner Van Kralingen will carry out this demonstration by shipping objects from 2 of the partner museums. And thank you very much for your attention. For any question, please, or clarification, draw us an email.